Can you tell the difference between the washing powder and the soda crystals? Hi, welcome to Grandad's Shed. I'm going to have another play with the electrolysis. One of the items of feedback I had was, why did I use washing powder, not soda crystals? The answer is, I didn't have any at the time. Now I do. So, I have two pieces of metal set up in the containers here. Both the same, just welded to a screw. And I will run an experiment side by side. On the left, we shall have the soda crystals, and on the right, we shall have the washing powder. I've measured out the same quantity of soda crystals and washing powder, and the setup is as before. We have the negative of the car battery going to the material we wish to clean up. I have made a same size electrode for both containers. In this case it's a tin of beans cut in half. That goes to 2 meters, so I can look at the current through each of them as the experiment progresses, and that goes back over to the positive of the battery. Now, let's put some water in these and set it up. That should be the same quantity of water to act as a dilutant. Let's turn on the meters. Put that one to amps. This one has to come around to amps. Both those meters have the same scale on. You can't see. Now just with the tap water that's in there, they are both approximately 0. That's the scale of amps, so both quite small. Soda crystals. Washing powder. Let's for a minute just talk about why I've decided to do both in parallel. This ensures that the battery voltage is the same across both of the solutions that are in the experiment here. Therefore, each solution will take current proportional to its resistance. Both have begun fizzing. The current of the washing powder is slightly behind. I'm going to put the GoPro onto Timelapse and we shall watch this experiment progress. It's been running now about 5 hours and the liquid of both of them has gone a bit sludgy. Consistently as I've been coming back past, the washing powder has been taking twice as much current as the solution of soda crystals. It could be just that there's more free ions in the washing powder. So we shall continue to leave these overnight now. The consumption of this system is totaling 1.5 amps out of the battery, and I've got a battery charger hooked up to that at the moment. We'll see if it's still going in the morning. It's now been 24 hours and we can see that the soda crystals on the left are still going strong. They're pulling 360 milliamps, while on the right the washing powder has dropped to only 100 milliamps. Now what I'm going to do is I'm going to pull each of them out in turn and have a look at it and see how clean each piece is. At this stage I don't think there's a clear winner. Both are still quite black. They both have significant levels of rust still on them. So I'll put them back in, leave them another day. Just came to check on it this evening and turns out that the washing powder has developed a problem. The soda crystals are still fizzing nicely. Washing powder, however, we can see all the way through. On the back here, it's dissolved away the electrode. So I'm going to have to make a new one. All the sludge in the bottom is the dissolved electrode. So I think that's why people don't use washing powder. Let's see what's left. Oh. It's just completely turned it to mush. Now, got the lid of the tin of beans. I'll bend that round a bit and drop that in there like that. Connect that back on there. Give it a bit of a stir around. That's better. We're going again now. 1/4 of an amp into the washing powder, 400 milliamps into the soda crystals. Let's leave that set overnight. It's been 48 hours now, and we can see that the soda crystals still ticking along nicely, and since I've replaced the electrode for the washing powder, that's been good overnight as well. I'm going to continue to let those cook along. The end of the electrolysis experiment, that's been 3 days I've left this sitting here for. I've finally got bored of watching it. What have I learnt in that time? Oh, that's cleaned up the soda crystals, and this is the one that was used in the washing powder. Slightly different surface colour finish to them, nothing major. Both appear to be clean. So we can see that that's taken off all of the surface rust, as has this one. Something that was very apparent at the start was the electrode damage that had happened. The washing powder has completely turned the electrode to sort of fine silt that's sitting in the bottom of the vessel there. That was half a tin of beans that was used for that. What did it actually do? It just turned it to rusty dust. I think this is the protective coating that the inside of a food tin is covered with to preserve the or prevent the metal coming into contact with the food stuff. This is the lid of that tin. See that the only thing left holding it together is the protective film. Everything else has been eaten away by the washing powder as electrolysis. As a comparison, I'm going to pull the electrode that was from the soda crystals. Oh. This is very much still recognisable as a tin. Has gone rusty, but it still has a fair amount of its strength, and I suspect would continue to work as an electrode for a little while yet. So soda crystals, much less aggressive on the sacrificial electrode. Finished product, virtually identical. Electrolysis does work using washing powder, but better with soda crystals is my analysis from this real science. If you're after a quick electrolysis experiment and can't get hold of soda crystals, then washing powder does the job. Just be aware that your sacrificial electrode is truly sacrificial. Thanks for watching.